Hey everybody, welcome to Bill Sky, the COBOL guy, and this is our third video in the COBOL series. And what we're going to do today is we're going to talk about data. Now, you can't really do anything with a program other than print hello world and static strings or static numbers until you actually have data, because that's what programs work on. Data, data, data. And COBOL is a really strange language. Actually, back when I first learned it, back in the 70s, actually it was the early 80s, late 70s, early 80s, it made complete sense to me because that's pretty much all we had other than an assembler language and Fortran. But the strange things about COBOL today is that COBOL is what we call a structured language, and it's also structured in its data definitions. Everything works on structures. If you know C or C++ or even Java, you'll know that there's this data structure called a struct or a structure, and it structures data into what we call an abstract data type. So you can create your own data types using the built-in data types of those other languages called a structure. But in COBOL, pretty much everything is a structure. And the reason for that is so you can easily write that structure to a file or read it from a file, because that's really what business programs are all about, are storing the data, updating it, deleting it, reading it from a file, all of that in structures, because rarely is data just a single variable. It's normally a collection of variables. So we're going to talk about that today in this video, so let's get going with some COBOL coding. Alright, so I'm here on Linux. Now I'm using Linux just because it's easier in general. And you can do the exact same thing on Windows. And we're going to be using GNU COBOL today. And I'm going to go to my COBOL projects and I'm going to create a new folder called Data Definitions. And within there, I'm going to right click and I'm just going to say create document COBOL template, and I'm going to call this main.cbl. Now, if you don't know how I just did this on Linux, go back to the previous video on creating your first program, and I'll show you how to do that, creating that template. So I'm going to go ahead and open this up, and as you can see, we have our base hello world program, and let's concentrate today on the data division. Now, the data division has a number of different sections. It's got the file section, the working storage section, the linkage section, and it also has the report and the screen section. And we're going to get to all of those in this course. But the first thing we want to do is we want to look at the working storage section. So in the working storage section, what you want to do is when you define data, there's a number of different ways that you can define it. You can define it as structured data, or you can define it as unstructured data, but let's do the structured data first. So when you define structured data, each piece of data has a level. Now before I do that, I talked about structures in the introduction to this video. So let me show you what a structure looks like in C or C++ if you're not familiar with that. So what you do is you say struct and some data. Let's call it employee data. And within that structure, you specify different pieces of data. So for instance, I'm going to say employee name. That's a char of 32. I'm going to say employee phone. That might be a char of, I don't know, 12 or 18, whatever you want to do. You might have something like employee salary. That right there might be a double. Now this is what we call an abstract data type. You've got a new data type called employee data, and each employee data piece of data contains these three things: employee name, phone, and employee salary. Now I did define those correctly, I believe. You might even want to have employee date of birth. Now employee date of birth really hasn't been defined yet, so you might want to create another structure called date, and within date you've got the month, you've got the day, oops, and you've got the year. Now I'm actually doing these completely incorrectly. Normally in C and C++, what you'll do is you'll give it the data type, and then you'll give it the actual variable. So let's fix that. And I believe that was year. And we'll fix that down below as well. Okay, so down here on employee date of birth, I can actually, let's do this right. We're going to say date, employee date. We're going to say double employee salary. We're going to say char 12, actually char employee phone. Char, yeah, I think it's this way. Well, I'm having a senior moment here. So let's get this right. There we go. Okay, so you can even see right here is I actually have an abstract data type defined within an abstract data type. So here's my date abstract data type. It's got 3 integers in it, month, day, and year. We've got employee data, which has an array of chars called employee name, an array of chars called employee phone. You might even want to break that into a phone number structure. Or you even have a double employee salary. But here's where it's kind of cool. You've got a date structure inside of an employee data structure. So that's what I call structured data. Now, COBOL works completely on that idea of structured data. And each structured data has a level. So what you do is, let's say if we want to do that employee data thing, I'm going to create a variable called employee data. And if you notice, it has a number 1. That 01 means it's the top level definition. Now, let's go ahead and create the next level, which is going to be employee name. Now, employee name is like an abstract data type or structure within employee data. And within there, we're going to say first name, last name, middle initial. So that is our beginning structure of our employee data. Now, one other thing we want to do, or we want to, let's say address. So let's just call it address. And we're going to say number, street, zip code. And you can do these as all capitals. It depends upon the compiler you're using. So there we go. Now I actually like using just spaces in COBOL instead of tab characters just because it's safer for the compiler. So we have a variable called employee data, or we have a structure called employee data. Within that structure we have employee name, and within that structure we have the actual 3 pieces of data: first name, middle initial, and last name. Same with address. Address has 3 pieces of data within it: number, street, and zip code. Now, one thing that we haven't defined here yet is the data types. So what we're going to do is, because employee name is a structure, you don't actually give a data type to a structure. You put the type of data in the variables underneath it. So what we're going to do here is we're going to say pick. So pick is a keyword in COBOL, or picture is a keyword in COBOL that specifies just what the data looks like. Now, because a first name in the global, on the planet Earth, it can include all kinds of different special characters. So what we're going to do is we're going to say X, and we're going to say it's, I don't know, say 18. Now what the X means is that it means any ASCII character or EBCDIC character if you're working on a mainframe. So X means anything. It could be a period, a dash, a letter, a number. It can be anything. Okay, so that's going to be 18 characters long. The next one, and this one I'm going to just use pic. That is the abbreviation for picture. Last name, and let's make that longer, 32. And just so everything can be lined up, let's go ahead and change that to pic. And then middle initial. Now middle initial, I've never heard of a middle initial ever being anything other than an actual letter. So what we're going to do there is we're going to use a different data type, A, which is basically a alphabetic character. Okay, so let's take a look at address. Now the number on an address, what would a number look like? Well, you could use an X. You could say pick X, I don't know, maybe 8. You could do that, or you could specify the number specification of 9. Now, within there, I could say, let's say the number's never going to be more than 5. I could do that, pick 99999. Or I could say 95. So there's numbers of different ways of doing that. And let's stick with the 99999, just so you can see that we do have that. Okay, street. I think for street we might want to make that X24, and for zip code. And zip code can be a number of different types. Zip code can be 5 numeric digits. It can be 5 numeric digits followed by a dash followed by 4 numeric digits. So there's a number of ways you could do this. I could say 99 and leave out the dash. Or what I could do is I could say 95-94. So I could do that as well. Now let's go ahead and save this. And let's try to build it, and let's see what kind of result we get. Okay. We call it main, so let's just leave it as main. And what the problem here is that we're using reserved words. That's one thing we haven't talked about yet. COBOL has, just like every language, COBOL has reserved words. Address, number. There's a number of reserved words we're using here, so we're going to have to rename these variables. And you can see right here, it doesn't actually say reserved words, but those are definitely COBOL reserved words. So we have to rename our variables a little bit. So instead of address, let's just call it employee address. Instead of number, let's call it street number. Or no, let's call it house number. And I believe first is a problem. So we're going to say zip code first and zip code second. Now let's build it, and it built just fine this time. Now this program doesn't do anything. I can run it, and it just says hello world. So those are the different types of data that we can have. Now there's a lot more. Let's go ahead and let's do some more stuff here. So I'm going to say employee pay info, and underneath that I'm going to put, let's put that in the right spot here, hourly rate. Now what can we do with hourly rate? Well, I'm going to say, now normally you have an hourly rate of like $9.99 an hour or $51.22. So we need a decimal point. So I'm going to say pick 999 V 99. And the V stands for a decimal point. So that is a floating point number that we have there. Now another thing we could have done is we could have said 93 V99. But you know, you have to kind of look at it and say, well, what takes less effort? So the V is a decimal point that's going to be part of the definition of the number. It's actually going to be a floating point. You could put as many here as you want. You could say 99. So you could have the maximum value could be $999 and 0.9999 cents, 0.000. You know, you just don't do it that way. So let's just leave it that way. Now the other thing you can do with numbers is, if I print the house number for employee address, and let's say the house number is 123, but notice that it is 999, there's 5 nines. And if the house number is only 123, what it's going to do is it's going to print the zeros ahead of the 123. So another thing that you can do is you can specify Z's instead of nines. And what that'll do is it'll zero suppress that number. It's like a 9 with zero suppress up in front. Let's go ahead and build that. Everything looks good. So that is how you structure the data. Now again, why is it a good idea to do this? Why does COBOL do it this way? Is because this data, you're not just going to have this data in a program and then it's just going to go away when the program ends. You're going to want to store that data into a file or into a database. And by creating structured data in this way, it makes it very, very easy to read it. Also, you know the exact size of the data. You know that the first name is always going to be 18, the last name is always going to be 32. Makes it very easy to read data out of a file. Now, one thing that we didn't do here is that we didn't default any values in any of these variables. Now, normally for string variables like this X or the A, you normally don't set those. Maybe you set them to spaces, something like that. But a lot of times for numbers, you'll always set those to 0. So what we're going to do here is I'm going to put value 0. So when you're talking about initializing a variable in COBOL, you give it the value keyword, and then, you know, whatever the value is going to be. Let's say the zip code we're going to do for value, I don't know, 1, 2, 3, 4, 5. You can do that as well. So let's go ahead and save and build that. All right, looks good. Normally you do it as 0, so that's what I'm going to do. Is I'm just going to change that to a 0. And we'll do that down here. Now I could have left off the 0.0, but you know, it's kind of nice self-documentation. All right. So that's structured data. Is that you define your data in such a way where it's structured, it's related. So all of this is employee data. Now, one thing I did in the structure example at the beginning was we created date of birth. We could do that here as well. Employee date of birth. Let's just keep it. And we could say year. Let's not. I think year might be a reserved word, so I'm going to say employee date of birth year, and that's going to be a pick 9999. Let's default it to a value of 0. Employee date of birth month, pick 99, value 0, and employee date of birth day, pick 99, value 0. Now this is another good example of where you might want to put a Z in front, because let's say if they were born January 1st, do you really want it to be displayed 0101? Maybe. So, but you could do this, 09. You could do something like that. But what we're going to do is we're going to leave it as 99. Something else you can do is that you can put a filler in there. I could just do something like, well, I could do it this way too. I could have defined this as pick 92, 92, 94. I could have done it that way as well. The problem with that, though, is that you can't really access each piece of data separately. So we're gonna keep it like this. So here's some of the really flexibility of COBOL. I'm gonna go here and I'm gonna put in a 10 level variable, but I'm not going to put any name in it. I'm just going to say it's a pick X, and I'm going to give it a value of slash. Kind of weird, huh? Let me go ahead and copy that down here. So now if I go down here to the procedure division and I say display employee date of birth, what is it going to display? Let's go over here. Let's build it, run it. You notice how to put the slashes in between the year, the month, and the day. That's really neat, right? You're never going to have a situation where you need to modify these. Maybe you might want to. You might want to call it a YM separator or MD separator for the next one, because maybe you might want dashes or slashes. But if you never need to modify those, just don't give them a variable name. It's just kind of like filler data. And then you can put the data in the date of birth, and let's do that. So I'm going to go ahead and say display. Now this is a piece of code that you've probably never seen before. I'm going to say move, and let's say 2023 to MDB year. Move 12 to MDOB month. Move, I don't know, let's say let's say Christmas 25 to MDOB day. And then we'll say display MDOB. Now, yes, believe it or not, you have to use the move statement, so MOVE instead of the equal sign. You might notice, and during this course, I might just type in MOV because that's what you do in assembly language. So let's go ahead and build that and run it. So you can see how it's kind of nicely formatted, right? Now, I set this up in such a way where the date of birth is the years first, then the month and the day, because that's sortable. When you have a day, month, year date, it's not as sortable. Now, we can redefine this data. I'll show you how to do that in a future course. But you can see how we moved data into the date of birth, into the year, month, and day, and it now has a value. Pretty neat, huh? I think so. Okay, so something else, another way to define data in COBOL in the working storage section, if you don't have structured data, let's say if you just have, I don't know, like a counter. Well, it wouldn't make a lot of sense to create a counter using an O1 level because it isn't a structure. So for unstructured data, we use a number called 77. So the 77 level means that it's not going to have anything related to it. It's not a structure. It's just a general variable. And I'm going to call this one loop counter. Now, a loop counter is almost never a floating point. It's never a floating point. It's a counter. It counts from 0 to 20. So we're just going to say pick 9999. So that's a loop counter. And you can do a lot of different things. Let's say if you have some temporary variables. Temp month, pick 99. Temp year, pick 99. Temp day. I think temp year should be 9999. So you can do that as well. And you do those exactly the same. You process those exactly the same as you would structured data, except it's not all built in. And if I print loop counter, it's just going to print loop counter. If I display temp month, it's only going to display temp month. One thing that I don't think I mentioned is that notice when I said display employee date of birth, it displayed everything underneath employee date of birth. It didn't display everything underneath employee data because we didn't say display employee data. We said display employee date of birth. So let's go ahead and build that and make sure I didn't type anything wrong. Oh, I certainly did. Line 43, what did we do? Oh, forgot a period on line 42. Just to make sure. Okay, so that is unstructured, what I like to call unstructured data. Now there's also a thing called enumerated data on COBOL. And what that means is that you can, there's a thing in C and C++ called enum, where you specify a value and you ask it if it's equal to that textual value. It's kind of hard to describe, so let's just go ahead and create it. I'm going to create a variable under employee data. Under employee data. And let's see, I'm going to create one called married. Pick X. And underneath there, I'm going to put in an 88. And this is the enumerated value. So I'm going to say employee married, and I'm going to give it a value of Y or a value of lowercase y. I'm going to say employee married. Nope, that's wrong. Oh, employee single. I'm going to give you a value of capital N or lowercase n. Now it's kind of hard to see what I mean by that. So let's go ahead and do a little procedure division example. And what I'm going to do is, again, we're going to do some coding here just to display what the data definitions look like. I'm going to move, there I go with the MOV again. I'm going to move a lowercase y to married. Now let's go ahead and make sure I don't have any reserved word problems in here. Okay. So I'm going to move y to married, and then I'm going to use an if statement. Now if you don't know what an if statement is, you're a little bit behind. That's okay because I haven't taught it yet here, but I'm kind of hoping that you've done a programming language before. An if statement is a logical statement that lets you make decisions within a program. Now I know this is a grandiose comment. This is like way overhyped here. But the if statement is the basis for artificial intelligence because that's what your brain uses, right? Your brain uses if statements. You're asking yourself questions all the time. So the if statement is just like it is in any language. I say if, and I'm going to say employee married. Then I'm going to say display employee is married. Else display employee is not married. So let's see how this works. Let's go ahead and build this. Oh, forgot an else. What did I, oh, yep, I put periods. You only put the periods at the end of the if. I forgot the end if. So we'll talk more about the structure of an if statement as the course goes on. And let's run it. Okay, employee is married. Now, what is the purpose of this 88? Well, instead of having to say if married equals yes, and I'd have to do an or. I'd have to ask multiple questions to see if it's equal to a Y or a capital Y, or if it's equal to an N or a capital N. It's much easier to just do this. Thank goodness for undo, right? Just say if employee married. And what it does is it checks to see the married variable to see if it has a value of Y or capital Y. Then employee married is true. If it's not, let's go ahead and move a capital N there so you can see it. Not sure why my insert key isn't working, but that's okay. Let's build it. Employee is not married. So that is what enumerated data types are. And we'll do more on if statements later on. But that's what the 88 data type is. So that's the basics of creating data in the working storage section of your COBOL program. And before I go on, what I want to do is I want to talk about all the different data types that you can have inside of the pick. So as I said earlier, you can have an A for alphabetic, you can have an X for alphanumeric, you can have a 9 for numbers only, you can use a V for specifying a decimal point location, you can even specify a slash for like a date. Some other ones are you can specify a Z, which is zero suppression of the upper bits, or the upper bytes, I should say. We did that in our example. We did the value, so you can initialize a value or a piece of data with a value. And within the data division, you can also create arrays. And that's one thing that we're not going to do in this video. I'm going to do it in the next video. But that's the other thing that you can do, is you can create arrays within the data division. Now, there's one other thing I would like to show you, and that's constants. So a constant is a value that really doesn't change. All of these are variables that we've created, but I would like to now create a constant. So a constant, there's a couple of ways of creating a constant. You can create a constant with a data type of 78. It's not really a data type, but a level of 78. So I can say, I don't know, months in year, and I'm just going to say value 12. So that's a constant, months in year. And if I go ahead and build that, and if I come down here and display it, we should see 12. There we go. So that's one way of creating a constant. Another way of creating a constant is I could make it an O1 level. I don't know, days in January. I hope I get that right. So I could say an O1 level, and I could say constant as 31. So that's yet another way of creating a constant. And let's go ahead and display that. And there you go, works just fine. So that's what the 78 and the constant keyword is about. One other thing when defining data that I would like to talk about, and then we'll be done for this video, is how can you name variables inside of a COBOL program? Well, they can be capital A through Z, they can be lowercase a through Z, they can have numbers 0 through 9 in them, they can have a dash, or they can have an underscore. And it's very common to use dashes and underscores in your variable names to make them clear. And if you look at this data, it's really self-documenting, right? I'm not really sure if ZC second is self-documenting. Maybe something like that would be better. Zip code second, zip code first. So that might be better. And it's really important to name your variables so they're very self-documenting. You might want to put an underscore, house underscore number. So let's go ahead and build that. And it looks like I've got a problem here. Oh, I think I left out a period or something, or maybe, oh yeah, that's because of this right here. So those are the different types. And the other thing that you don't want to do is you don't want to create a variable that begins with a number. So let's try that. So I'm going to say 77, 22 variable, and let's say pick 99. Let's see what happens if we start our variable with a number. It took it, but this is not a very good way of doing things. You can't create a variable with a hyphen or a dash. Names that begin with may begin with a digit, but they have to have at least one letter. So like for instance, if I created 22, that won't work. But if I create 22i, that will work. Now, is this a good variable name? It's not a good variable name, not at all. So let's just create this. Yeah, and again, most languages don't allow you to have a number as the first digit, but you may see it if you look at COBOL. So I'm going to call this some variable. Now, one other thing I want to show you is I'm going to create another variable, all capitals, with the exact same name. And let's see what happens when we build that. Now, GNU COBOL lets you do that. It looks like GNU COBOL might differentiate between uppercase and lowercase variables. However, IBM COBOL, Micro Focus COBOL, the other ones don't allow you to do that. Everything is considered uppercase. And that's why you might notice in a lot of COBOL programs, everything looks uppercase, because that's just the way it used to be. There used to be no differentiation between lowercase and uppercase. So it's a good idea to get into that habit. But in the case of GNU COBOL, let's actually see. So I'm going to move 10 into some variable. I'm going to move 20 into some variable. And then I'm going to display the lowercase one. And why am I doing this? Well, I want to see if these two are different variables. I believe they are, but this is how you can test it. I move 10 to some variable, then I move 20 to some variable. If they really are the same variable, when I display the first sum variable, it should be a 20. Let's see how it goes. Oh, look it. So now we've got a problem. So GNU COBOL, it allowed me to create these variables up here, but it didn't tell me they were ambiguous. It didn't tell me that I was redefining them. It didn't see it until I actually did it in the procedure division. So even GNU COBOL, everything is uppercase. It doesn't matter. Even if you have it as lowercase, it's uppercase. Let's go ahead and fix that. Yeah, it's interesting how that works. Each compiler is a little bit different, so let's go ahead and put that there. Make sure we don't have some other error. Oh, forgot the word to. So let's go ahead and change that. Move 22. There we go. All right, great. Okay, so again, uppercase, lowercase doesn't matter. Whoa! Data types in COBOL, data definitions. Play with it. Mess around with it. Look at the GNU COBOL manual. I'll put a link to it in the description of this video. Play around with those values. We did a little bit of coding in the procedure division. Actually put some data in. Experiment with it. Mess around with it. Try floating point numbers. See how those work. The next thing we're going to do is we're going to talk about redefinition of data and arrays. So hope to see you at our next video.